Today we're going to be working with special right triangles, we have two special right triangles, but I will be showing you um, three diagrams that we have here today. So to start us off, these are going to be applying to the unit circle, and we're going to be talking about how to get these particular angles, as well as how to find the coordinate, why they look like the way they do, and this is on a unit circle itself. So to start us off, your unit circle has a radius of 1. So your radius here from tip to tip. So if your radius is 1, that means that any branch that we decide to try and extend from the origin out towards the outer wall of this circle is going to have 1, meaning that this line in blue will also equal 1. Now notice that in this case, this green line is not at this 1/2. So how on earth will we determine this coordinate or this value here? Right, well, when it comes to that special right triangle, right triangles, we can use the Pythagorean theorem. A squared plus b squared is equal to c squared. And if we can have the understanding that because this is a pi over 4, meaning that this is a 45-degree angle. And we can tell that it's a 45-degree angle because all angles add up to, well, all triangles add up to 180. But this first quadrant right here, if we go from this 0 all the way up to pi over 2, we have now gone and done a 90-degree angle. And notice that we have now cut this 90-degree angle in half, meaning that this angle right here, half of 90, is a 45-degree angle, or in radians, pi over 4. So that just means that because we've cut your graph in half, and I'll show you your graph to start, that just means that this leg here that means that the opposite angle, so this leg here, will similarly be the same leg over here because this triangle, right, this is also a 90-degree angle here. And that just means that this over here is also a 45-degree angle, or again, pi over 4 in terms of a radian measure. So 45, 45, and 90, they all add up to 180 degrees. So that just means that these two legs are the same. And with your Pythagorean theorem, we'll call this A, B, and C here. So we already have C, coincidentally, because this is your radius. So C is equal to 1, and A and B are equal to one another. So if we take your Pythagorean theorem, I'm going to rewrite it so now we have these two values showing because B is actually just the same as A. We now have 2A squared is equal to C squared. So if we're trying to solve for A here, we want to get A alone and on one side. We can say that we're going to divide both by 2. And then now we have this radical, or sorry, now we have this square. So we're going to square root this whole thing. Now, typically when you make your own square root, we have to account for the positive and negative. But because we're talking about a measure or a distance, we are only working with a positive number. Now, from chapter 1.2, we talked about how to simplify something like this. So if we have the square root of c squared over 2, this is just saying that we can break up these two and evaluate. Now, c squared is easy because it's just itself, because it's squared and square rooted, so they undo each other. But you still have the radical of 2, meaning that we want to rationalize, meaning that we are going to multiply by itself. So we get the square root of 2 times c over 2. Now we said earlier that c was your radius, meaning that c is equal to 1. So really we'll replace that c and we'll just say we have now root 2 over 2, or 1 times root 2 over 2. So if that is what your A value is here, so if this is A, root 2 over 2, and B is also equal to A, so it's also equal to root 2 over 2, that just means the coordinate right here, right? Your coordinate is just x comma y. Well, your x value, right, is really your A is root 2 over 2, and your y value as well is root 2 over 2. So we have the coordinate as such. So when we talk about your proportion for a special right triangle, for a 45, 45, 90. So 45, 45, 90, or a pi over 4, pi over 4, and pi over 2. On the unit circle, when we talk about the unit circle, right, this 90 degrees, well, this is just another way to say this is your radius. So that is going to be 1 here. So your proportion for your 90 degree is 1. And then these measures here are the root 2 over 2 and root 2 over 2. Now, typically, the ratio that we see without the unit circle, we usually have, we'll just say A, and A root 2, right? This root 2 is just coming from here, right? It's just saying that these, excuse me, these two values are the exact same. And then this has the portion of itself multiplied by the root 2. So this ratio will only apply when it's a unit circle. And this is the regular ratio. So if we didn't have a radius of 1, instead, if it was greater than 1, right, that's when we can change it and apply. But for us, our unit circle is going to have a radius of 1. Now let's see some of your other ones. So you'll notice that we now have this, this one. Now again, your radius here is 1, meaning that your hypotenuse, your C value here, is also equal to 1. Now this triangle is nice because this here, right, we have at least one of your values. Your coordinate for your x value is 1/2. We know that because we can see this clear line right here being this 1/2. So we can say A is 1/2, meaning that we have to now just find your B value. Now we know that this is this 1/2 angle, or sorry, this 1/2 measure, this is going to be opposite of a 30-degree angle. So if this is where your 90-degree angle is, and we had another 90-degree over here, but unlike last time where it was cutting your 90-degree in half, we don't exactly know this proportion. But if we can understand that anytime you have a half measure on your unit circle, that directly across from it will be a 30-degree angle. And again, that's going to come into play with your proportion. So a 30-degree angle, this being 90, and if all triangles add up to 180, we are just missing this 30 or 60 degrees. So across from this 60 degree will be this B measure. So let's take the unit of your Pythagorean theorem once more. So a squared plus b squared is equal to c squared. And thankfully, we can already substitute values in because we're going to be solving for b here. We don't know what b is. So we said a is really just 1/2 squared plus b squared is equal to your radius, c squared is 1. So when we go to solve, right, we can put everything to one side. So we have 1 squared minus 1/2 squared. And then we can start to whittle it down. So 1 squared is 1 minus the square root, minus the square of 1 and 2. So that's just 1 over 4. This is now just really 4 over 4. So we have b squared is equal to 3 over 4. And again, we need to get b alone. Right now it's squared, so let's go ahead and take the square root of it, so 3 over 4. And again, let's break it up to have its own square roots. And again, this is coming from chapter 1.2 where we learned how to do this. So if that's a little rusty, please go back. So now we have the root 3 over 2. Now that is what b is over here, root 3 over 2. So that means this coordinate is 1/2 comma root 3 over 2. So your ratio of your 30, 60, 90, or pi over 6, pi over 3, and pi over 2. So we said this this pi over 6, let's see, pi over 6, there we go, is your 1/2 root 3 over 2 and 1. Now the typical ratio of it is, for your 30, 60, 90 is 2, not 2, is, let's say, x root 3, and 2x. So it's just saying that these values here, that the 90-degree angle is double the 30-degree angle, or 30 degrees is 1/2 of the 90-degree. So let's start again with your last diagram. So this one is a different measure, but it's still evaluating the same special right triangle. Now this time, your x value is not 1/2. So 1/2 is right here. And that just means that we now have a little bit more than 1/2 and not quite 1. However, we do have your radius. So your radius here is still 1. So c is still 1. But notice that your y value is going to be that 1/2 amount. So a here is equal to 1/2, or 0.5. So far, we have some x value, comma, 1/2 as your y value. And again, straight across, so if we know that this value here is 1/2, and we're dealing with a 30, 60, 90, so this is our 90-degree angle here. So straight across, that means that this angle must be 30 degrees, or pi over 6, which means that this degree here is the 60-degree, or pi over 3 amount. And you'll notice that we have this pi over 6. It's not that this angle is this one over here. It's just this whole measure right here, if we keep branching it out towards the very edge of our circle, that this amount is that 30-degree angle, or pi over 6 radians. So if that is what we have, again, we don't know what this angle is or what this measure is unless we take our ratio here. We said our ratio for pi over 6 is 1/2. Pi over 2 is 1, so the missing side is that root 3 over 2. So this should be root 3 over 2 for your x value, which that should make a little bit of sense, because if it was pi over 4 over 2, or sorry, the square root of 4 over 2, so a little bit more than 3, that would be 2 over 2, which is equal to 1. So this portion here is just an additional amount that we don't have. So root 3 over 2 is just less than 1, which we can see from your diagram over here. And again, if we wanted to calculate it that by hand and just double check, we can say this is your b. This again is your b, or your a. If we wanted to stick with it, we could say totally that one is your a, and maybe this now is your b, and we're trying to find a. We could still take it and do the exact same. A squared plus b squared is equal to c squared. Well, we have, we don't have a, but we do have 1/2, which is your b, and your c is just 1. So you have a squared is equal to 1 squared minus 1/2 squared, which is equal to 1 minus 1 over 4. So a squared is equal to 3 over 4. The square root of it, So root 3 over 4, or square root of 4. So there we have root 3 over 2. So A is root 3 over 2. So again, your distance over here is root 3 over 2. So that is the coordinate for pi over 6. And that is just by using these special right triangles. Again, this is the ratio for the special right triangle on a unit circle. I hope you found this video informative as far as putting your special right triangles onto your unit circle and just talking about how some of these coordinates come up using these special features.